So hello everybody, and welcome to the third ever Virtual Bash. I'm your continuity announcer, Garth Gilmore, and in the background we have Ryan and Zara who are doing all the hard work. So just a few announcements before we begin. So first of all, I have a note from Zara to say that we are past 2,000 subscribers, which is excellent, wonderful. Thank you so much. That is absolutely brilliant. Yeah. Then I have a note from Ryan reminding me that it's been a tremendous week in the world of association football. Yay. So congratulations to whichever team have won or retained the Ashes. So go local sports team. That's excellent. Yeah. Turning to more important matters, I will be presenting at the London Kotlin user group on the 1st of July. So I'll be talking about generics in the Java virtual machine in general and Kotlin in particular, and how the Kotlin syntax improves on what you have in Java. It extends it, it simplifies it, it makes it easier to cope with the problems of co and contravariance, and reification and erasure and so on. So I'm sure you're all incredibly keen to attend that. So Zara can put a link to that in the YouTube chat. Then next, one of our presenters, Richard, he will be joining with 5 others, and they're going to be doing a sponsored cycle for Storehouse Belfast. So they're going to be cycling all the way around Ireland, and I don't think there's a single hill that they're planning to avoid. So they will be racking up a tremendous amount of mileage and altitude. So he can tell you more about that during his talk, and we'll put the sponsorship link up again in the YouTube chat. So then turning to upcoming Bash events, we have a July Bash planned, and this will be the Software Craft Bash. So we will be discussing, should software development be a profession? Should it have governance? Should it have its own aesthetic? Should it have a code of conduct and so on? Or are we just, humble code dwellers hacking out code at the bidding of management? So that will be the topic for July. And then the August Bash will be the Writer's Block Bash. So we have a tremendously experienced technical writer coming to give us the benefit of her years of experience and wisdom. So we'll be talking about whether or not technical writing can be considered a specialization of software development, what it is, why it matters, how to get good at it, and so on. So that will be happening in late August. So turning back to today's topic, obviously a very important one. Serverless is something that's going to affect all of us in the next months and years, if it's not affecting you right now. And I anticipate there's going to be a large number of questions, so I'll try and get as many of them answered for you as I possibly can. But as your continuity announcer, I get the first and last question. So my initial question would like to be, when are we going to ditch all this YAML nonsense and return to describing services in XML like the good Lord intended? So that would be my first question. So with that hanging in the air, I would like to invite Chase, our keynote speaker, to turn on his video and his audio and join us. And can I just ask, what time is it where you are?
Yeah, it's lovely 4 a.m. here in Portland, Oregon. So this shows you how excited I am to be here, because certainly I would not be up at 4 a.m. if I was not super excited to be talking with all of you. Normally I'd have to get on a plane for 10 plus hours to go and get a chance to meet and greet with everyone. So there's a silver lining to everything that's going on.
Excellent. So is this very late or very early for you?
This is very early. I did manage to get a decent amount of sleep.
Glad to hear that. Okay, well, I shall vanish and leave you to it.
All right. Thanks again, Garth, and everyone else putting this on, though I'm not sure that I appreciate Garth talking about this as though serverless is the next pandemic. It will happen to all of us. But it is true that serverless is becoming a very common pattern because of its power. I thought today that what would be interesting would be to talk about what you can do with serverless, not just for toy applications, but actually for more broad use cases where you might be wanting to take an application that already exists and refactor it. Maybe not the whole thing, but because that would take a really long time, and entire refactors of applications never go well. But maybe instead, what if we could pick apart and refactor bits of applications that would give us some benefit? So I'm going to share my screen here, and we'll pop over to a short presentation just to kind of tee things up. Of course, I'm sharing the wrong screen. I apologize. Let me switch this over. There we go. All right, so real quick, my name is Chase Douglas. I'm the CTO and co-founder at Stackery. Stackery is a platform that helps our customers design, develop, and deliver modern applications on top of AWS. And while we've done that, for people building new applications, we've also done this for people building lots of refactored, modernized apps. But let's take a step back and as this is the serverless edition of Bash, let's focus on why serverless is a thing in the first place. Businesses, they need to build applications to help their customers achieve some kind of benefit. But what we build is very different from how we build it. No one actually cares about the plumbing that goes into how the applications are constructed. Serverless itself, if we try to define what it looks like as you're building an application that you don't have to waste all your time working on the plumbing, it does actually look like a bunch of plumbing. It's often made up of lots of different services that talk to each other, although in this case, the services are taken off the shelf from AWS, your cloud provider, to manage authentication, to manage your database tier. But the key is that it's very microservice-like, and so you have to have mechanisms to manage that. The other side of serverless is that it's this form of a collection of managed services. So of course, you're not dealing with servers that are running in racks and data centers. Instead, you're dealing with these individual components of an application, that's software layered on top of those servers in the data center that you don't have to manage yourself. So there's kind of this array of a couple dozen services that people are very commonly associate with serverless. These are Lambda for functions as a service, SNS as a pub sub topic, SQS for queuing, API gateway, DynamoDB. These are all abstractions that you can take and ask the AWS to provision for you, and you don't have to manage the day-to-day operations of. The other side to serverless is that it's a mechanism to really match your utilization to what you pay. So if we think about in the long past, maybe not the past for some of you, but dealing with data centers where you have to manage individual servers that are racked. And there you have to really pre-plan and pay for the capital expense of buying servers before you need them, hopefully. And so if you're buying these servers before you need them, you're always having these upfront costs that are shown in purple here that you don't get any benefit out of. But instead, if you could track the utilization as you go, that'd be a much more ideal scenario. In fact, we could step through what this really looks like as you get more and more closer to a serverless position. So here, the red line is what you have to pay to rack physical servers in a data center. The blue line is what your actual demand is. And this could be over, I guess if this is servers, this is probably over the matter of weeks or months. But as we get closer and closer towards a serverless stance, let's say we move to the cloud, and now we have the ability to, with some API calls, manually provision servers up and down. Maybe our time series here, our time axis is, over a period of, days or even hours. We can manually spin up servers and tear them down, but we're still just kind of approximating demand. So there's still a decent amount of cost between the blue curve, our utilization, and the red jagged curve, which is what we're actually paying for. Maybe we start to throw in some auto-scaling algorithms that get us closer to meeting need exactly when we need it. But serverless itself, you literally pay for just the usage at the moment that you're using your resources. So you pay for the number of milliseconds that a function is running in response to one API call through API gateway. This gives you a huge amount of flexibility and helps you meet your cost, helps you meet your goals for tracking cost utilization. By doing this, you not only help potentially your production environment, but you actually help your overall total cost of operations. So as an example, Joe Emerson is someone who's built a startup for the insurance industry fully on serverless. And he's they're a happy Stackery customer. Their April AWS bill is just under $740. He broke that down. It's really interesting to see what their numbers are like. But what's important is that at the stage of a company that he's at in the past, pre-serverless, he would have easily been around 15K per month in AWS spend because of all of the development and testing environments that would have been spun up to similar capacities as production for proper testing. With serverless, you've got the ability for individual developers to spin up their own environments, but they'll cost you pennies to run because developers don't need to hit things with high throughput to test functionality changes. But serverless isn't just for greenfield applications, new startups, or new projects that a company is taking on. You can use it to refactor modern applications. This is what MasterStream, that's a company that's done a top to bottom refactoring of one of their applications. They moved from the data center into the cloud first, and they got the elasticity gains, being able to spin up servers on demand, tear them down, but their costs really shot up versus what they were paying on the data center. But then once they switched to a serverless approach, they actually ended up saving 90% on their AWS bill, and they got much faster in developing and shipping their software. But it's not all, it's not the easiest thing in the world. There are challenges to modernizing applications. There's with the old approach, you've got cost and scale problems for monolithic applications. You've got challenges with cost and agility of your development team. And you've got, if everything's a monolithic app and one route is really problematic, it has the ability to take down the rest of the application depending on its failure mode. There's a lot of great reasons to move off of a monolithic app and modernize it, but it is hard. You have to figure out ways of redoing your deployment mechanisms. You've got mechanisms that you have to figure out for, as you scale, both in terms of throughput, but also in terms of the size of the application. How do you factor that out into more and more services that are being managed by your service provider? Lots of challenges in this area, but there are key known mechanisms for doing this well. So if especially your application is an API service, a RESTful API, you can start to use API gateway as a proxy layer to pick off individual routes to refactor one at a time. And if you've got the right tooling that helps you manage this, you can actually do this very quickly. And that's what I'd like to show today. We're going to jump into a little bit of a demo. Let's imagine that we've got this two-tier application. It's old school .NET framework running on Windows servers in a data center. And we want to jump to modern serverless approaches for updating this application. It's a simple application. It's got a library with endpoints to catalog your books and your authors, but maybe the books route doesn't scale well. So what can we do to make this serverless? So I'm going to hop out of my presentation now, and let's take a look at what this application looks like. It's running inside of AWS, at least at this point. We lifted and shifted. We're using Elastic Beanstalk, which is kind of like AWS's version of Heroku. And I can hit this route, and don't worry, everything is fine. I just don't have anything at the root route. And we can see this API books route that is coming up. Comes up in traditional XML that Garth loves so much. So let's imagine that we want to take this, which is running on Elastic Beanstalk on virtual servers, and we want to move it into a serverless type of environment. Well, I'm going to hop into VS Code here, which is my favorite IDE. And I've got a project, kind of a blank project. It's got a blank CloudFormation or SAM infrastructure as code template that many of you may be familiar with. For others who aren't, it helps codify our resources that we're going to spin up. And I'm actually going to kind of do a split screen thing here and show what it's like to build up a CloudFormation template using Stackery here. So first, we talked about creating an API as a proxy for our existing API. And so if we hop into here, let's imagine we are going to first create a default route that will send everything that doesn't match what we're going to implement to the existing API that I've got. And then let's come into here. Let's take any method that hits API books and any method that hits /API/book/star in here. All right, so I'm starting to make some endpoints. I'm going to proxy, oops, I opened up the wrong one, proxy my default endpoints over to my existing API. So we'll copy this link address. Put that here. All right. So now I'm proxying that. We can see that we're building up this CloudFormation template over here. The next thing is we want to re-implement those books routes. So let's drag and drop a function here. We'll call these books, and I'll put those in my books path. And this will be a .NET Core 3.1 function. Yeah, looks like I had some leftover stuff. Well, all right, so now I can start to wire up my routes. All right, I got my books routes going to this books function. And then the last thing is this talk to a SQL Server database. So I'm going to drag and drop a database, but instead of creating a new nice Aurora serverless database cluster, I already have an existing database. So let's find out where that database is. I've got that open here, and here's the ARN of it. Where's that ARN? I swear I'm in the right tab. Here it is. And I'll copy and paste that. Put that down here. So I'm using an existing database instead of creating a new one. And I'll wire up my function to it. The last step that I need is I've got to have some credentials to connect to this database. The best place to store those is inside of AWS Secrets Manager. So I have them stored there already, and I'm going to drop down and grab a secrets resource here and wire that up. By wiring this up to my function, I've done a couple of things. I have added in permissions so that I can access the database secret inside of Secrets Manager. And I've created some environment variables here that give me the DNS address of the database and the secrets are in the port of the database somewhere in here. Yeah, the database port. I've got a location for environment-specific secrets namespace that I'll use. So I've kind of constructed this template here to create my application. And then the next step is I gotta write my code and port that over from my .NET Framework application. So what I'm going to do here is I'm actually going to pull up, and because this is a limited time engagement, I'm going to pull up what I've already built here in GitHub, just to kind of show what this looks like. So I called my function web API here instead of books, but I copied over the a bunch of the .NET application stuff from my .NET framework. I was able to copy over my book model wholesale from .NET framework into my .NET Core API, same as my authors model. I'll actually zoom in a little bit. I had to update a bit of my books controller, switching from the older .NET framework approach to .NET Core. So how they specify routes is a little different there with decorators, which makes things a little bit easier. So I was able to port most of the code. About 90% of this code stayed the same, and just about 10% changed. So it wasn't too bad. And lastly, controllers and data here. I updated the code to connect to my SQL Server database to get the database password from Secrets Manager. So here I've got a new Amazon Secrets Manager client. I asked to get the value of a secret in my environment, which might be /prod or /dev /db password. And once I got that that secret value back, I'm able to grab the password from it, get the database address and port for my environment variables, and create the connection string for the .NET framework. And so I put that into my source code and I deployed it out. And what we see here is a deployed version of my application. Apparently I came in and accidentally deployed in this random function2 resource. But leaving that aside, I've got this staging URL to play with for my application. We can see that I'm already starting to proxy the existing non-existent root route. But if I hop into /API/books, we'll see, because this is .NET Core, it's got a different default behavior of returning in JSON instead of XML. Sorry again, Garth. But we're already, using this .NET Core Lambda function to serve our responses in a more scalable way, alongside, say, the authors route, which we did not port over and is still in XML. So this is, really kind of hopefully giving you a sense of a pattern that you can use. If you're saying to yourself, I'd really love to use serverless, I've played around on the side with this, but even though there's benefits that in theory could be utilized at maybe my place of work, where we build older style applications, I can't figure out how I could bring serverless into this. Hopefully this gives you a sense of some mechanisms that you can use as tools to help you pick apart and re-implement little independent modules, API routes of applications, one piece at a time, to build in a serverless direction, hopefully giving you benefits of scaling better, lowering your cost, shipping features and functionality faster, all the great stuff that comes with serverless applications. I don't know if there were any questions that I might be able to answer for the next few minutes.
Absolutely, yes. Let me jump in. So first of all, thank you for an excellent talk, and I know how hard it is to do live coding at one of these presentations. Never mind at 4 in the morning. So thank you very much indeed there. Yep. So a few questions coming in. So first of all, whenever you're doing this and you're incrementally porting something, what would you aim to keep the same versus what would you aim to change? So for example, if you had an existing SQL Server database, would you just want to move that, into the cloud, or would you be looking to move it to DynamoDB and so on? So what would you be happy doing the same, and what would you want to change?
That's a great question. And a lot of it comes down to what's important to your project, your business. Sometimes it's licensing concerns and the cost of, say, a extremely scaled out SQL Server instance. And so it may be that actually the first thing you want to do is start to convert things into DynamoDB and SQL, or into Aurora Serverless ahead of any compute time refactoring. It could be that it's the compute side that's very problematic, and you really like to fix the two routes in your application that are so often erroring and failing for you in unpredictable ways. So moving them into Lambda could be the best way forward. Some of this, it's basically all kind of context dependent. And the customers that we've helped modernize, actually, many times they've taken that all on as one part. They haven't done it all at the same time, but they've transitioned some routes to Lambda for compute at the same time that they transitioned the data that those routes use into DynamoDB or Aurora Serverless. So it's very contextual, but there's a lot of flexibility here. So whatever is most important to you, you've got abilities to pick and choose.
Cool. And then just with regard to what we're looking at here, which I have to say does look very nice, should we be treating YAML more as a kind of intermediate format then? Should we be thinking about, not writing it ourselves, but letting some higher level tool like what you've shown create it for us?
Well, that's certainly my belief. Not that you should never jump into the YAML. There's places where we help you scaffold and edit the most common settings of resources that you might need. But there are times when you need to modify really advanced settings that most people don't need to, or you need to interact with resource types that are not very common. And it's always going to be important to be able to drop down to that lower YAML layer just to really customize things if you need it in the 5% of your application that needs that high amount of tuning. But from a day-to-day perspective, you probably don't need to to copy and paste the same lines of code and scaffold the same resource types over and over and over again. You want some kind of faster way of doing that. So having a visual abstraction really helps with that. And the next thing that it helps with is when you get to the point that you've built an extremely complex application, and I'll actually grab an example of that here. This is a 2,500 line application written in CloudFormation. And if I paste that into my template here and give it a second, of course, come on, demo gods. I know you want to work for me. And of course, it's not going to work. Let me pop over here. Sometimes you're working on really large code bases with a lot of resources. And there we go. And it can be hard to figure out what is connected to what. How are these relating to each other? So being able to parse this out and represent it in a visual manner, how this IoT topic rule relates to this DynamoDB table and this Kinesis fire hose delivery stream, helps people really understand where they need to dig in when they need to fix an issue, when they need to extend functionality, rather than having to start from okay, I've got a 2,500 line template. How do I figure out what all is connected to what to even just wrap my brain around how this application works?
Cool, excellent. And so just reading the questions here as they arrive. So Stackery specific question. How long does it take to adopt and support new AWS features? You know, what's your typical turnaround, do you find? For example, QLDB, I'm going to pretend I know precisely what that is.
Yeah, you know, QLDB is their managed, it's technically not blockchain, it's just the ledger component, but it's it is blockchain. It's not Bitcoin per se. But anyways, one of the awesome things about Stackery is that we've made it super easy on our side to specify how resources are manipulatable inside of our canvas. We have our own declarative syntax, our own DSL that we have internally to define how things relate and can be wired up. So it usually takes us on the order of hours to a couple of days to implement a given resource. So if you were wanting to use Stackery and you're finding that it doesn't have a resource that you want to use, feel free to reach out to us, and we'd be happy to chat about you know, the possibility of adding that to our palette of the most common serverless resources. In fact, it's not just serverless resources. You'll even see there's like Neptune here that we added in. One of our customers needed Neptune as a graph database. We were happy to add that in for them.
Cool. And do you support other cloud providers, or is it purely AWS?
Today it's AWS, although we're very excited, looking forward to adding support for other cloud providers in the future.
Cool, cool. And then the final question for the moment, just to ask you about one of the standard fears regarding, you know, AWS and serverless and cloud and so on. I'll phrase the question my own way. Is it like opening a bank account where whenever you're a new customer, you get the free wallet and the generous allowance and the credit card and the overdraft and so on, and then you come back a year later and they go, oh, you're an existing customer. Excellent. You know, let's talk about the rates, you know. So is there a danger that we'll go through some line in the sand and the powers that be will decide, okay, now people are locked in, let's start raising the charges? Yeah.
Well, first of all, AWS doesn't have a history of ever increasing prices. There's been like one or two scenarios where they've changed pricing and it was possible that for an individual customer it's gone up, but for the vast majority of customers it's gone down. Yep. So I don't have a history of jacking up prices. And the other side is there's a risk of lock-in, and let's be upfront and transparent. You are coding to a specific platform when you choose to jump in and build serverless applications. But in return, what you are getting is a vastly more scalable solution. You're getting a cheaper solution. As I mentioned, we see across many of our customers that when they refactor applications, so we know how much it cost in the past, they see their costs drop usually 80 to 90% when they choose a serverless approach on AWS. And you're getting something that with the right tools is actually easier to develop with and ship faster. So it's all about what's the trade-off that you're looking for here. Do you think that there's going to be a world a year from now where you're going to be unsatisfied and you're going to want to move onto a different platform? If you think that that's likely, then maybe serverless isn't for you. But that's something that basically I'm hard pressed to come up with companies I've ever heard of that have adopted serverless and then later on switched away from it. The only time I've seen anything get close to that is when people were frustrated they didn't have the right tools, so they never got their first project off the ground. But once people get their first projects off the ground, I haven't heard of anyone turning back.
Very good. Cool. Excellent. Listen, thank you so much. So wonderful talk. And we'll bring it back
real quick.
Yeah, cool.
I forgot to mention, if anyone wants to try out Stackery, it's free for individual use. It is a paid product for teams at companies, but if you just want to use this for side projects, check it out, stackery.io. You can sign up for free and play with it, create toy applications or side projects to your heart's content.
Very good, cool. So as I say, thank you so much. We'll bring you back for the group Q&A at the end. So if you can try and stay awake, so just drink espresso during the next couple of talks, and we'll see you again at the end. But if I can banish you for now, and
thank you,
and invite Matt to step up and deliver our second talk. Hi there.
Hey. So let me just share out my screen. Okay, so for anyone who has never heard of me before, my name is Matt Coulter, and I'm an architect working for Liberty IT, which is based in Belfast in Dublin. Liberty IT is actually part of Liberty Mutual, which is a Fortune 100 company that sells insurance products across the globe, and it's based out of Boston. A few years ago, we decided to try and take advantage of the public cloud in order to improve resiliency, reduce costs. But we decided that a lift and shift technique probably wasn't going to bring us the benefits that we needed. So we started adopting what we're calling a serverless first mindset. And in order to do that, it requires a higher level of knowledge and a higher level of implementation as to what you're doing on AWS. We have intimate knowledge of those massive CloudFormation templates that you just saw. And so what I'm really going to talk about is my journey from writing those CloudFormation templates to what I've been doing today, which is using AWS CDK. And you should hopefully see a lot of overlap between the problems being solved here and what you just saw. And if you've never heard of what we're doing in Liberty IT or Liberty Mutual before, just to give some cloud credentials to know that you can trust what we're saying. In the world of AWS heroes, there's only 21 machine learning heroes worldwide. I have 2 colleagues that are machine learning heroes. You have Gillian McCann, who you will hopefully have seen present at the AWS serverless function a couple of weeks ago, talking about how her serverless first mindset helped create WorkGrid, a complete spin-off company from Liberty Mutual. And then on the last Bash event, you'll have seen Gillian Armstrong talk about ethics. And outside of that, we've had teams like our team Outrun went to reInvent last year and came 4th in the world at building a machine learning model for the Deep Racer competition. So there's extensive, I have some amazing colleagues, and there's some extensive knowledge that you can draw on with this. Unfortunately, today you've got me and not them, but sure, we'll press ahead. So the serverless first mindset, if I distill this down to its absolute core, a lot of people go straight to technology when we say serverless, but what we're actually talking about here is a phrase that I have seen go back as far as the 90s, and it's probably been around even longer than that. Code is a liability. And what we really mean by that is if you let developers do what they want to do, they will just write code because we love doing it. And we love seeing if we can do it better than the last person who wrote that code. But the problem is day one, that's amazing. 6 months later, you have this massive code base that you now need to maintain. You need to keep it up to date. You need to patch the security issues. Whenever a new person joins the team, you need to explain why the piece in the corner uses some obscure technology that was popular 6 months ago, and you can't touch it now because nothing quite does the same job today. So the serverless first mindset is about saying, let's look at our entire code base and what bits are our unique selling point? What bits are unique to us that we really need to protect and develop and look after? And what bits is everybody else doing that's a commodity play? What bits can we just offload and not worry about so that we can focus on the business value, focus on rapidly delivering business functionality straight to production? So again, it's not about a technology. You might hear people say that Lambda is serverless. I would argue you can have a non-serverless Lambda implementation, which we can have a debate about later. The way that we find our liability is in LIT, we actually make extensive use of Wordly mapping. And you can see on the right, if you've never heard of Wordly before, you can follow Simon Wardley on Twitter, and he gives constant streams of his advice and strategy or you can go to medium.com, and that's his guide for how to learn the mapping. If you want to learn more about wordly mapping in a serverless context, again, another one of my amazing colleagues, Mike O'Reilly, actually presented about using wordly mapping for serverless at Serverless Days Belfast. But to give a whistle-stop tour so that everybody understands the concepts that I'm going to talk about later in the presentation, you can see that on the y-axis, what we have is this scale of invisible to visible. And what that's saying is the higher up you go on this graph, the closer it is to the end customer. It's visible to them. If you change it, they will care because they can see it. But the further down this graph you go, as long as it works, no one is going to say anything if you swap it out for a different component because it's an invisible subsystem. It's undifferentiated heavy lifting. And then on the x-axis, and this is where it gets really interesting, it's broken down into these 4 categories. Genesis is saying that this is something brand new to the world that you are prototyping that is going to be incredible. So in the case of, say, this graph is for a cafe. So this could be a computer vision model that is used based on the speed that somebody walks into the cafe, recommends a different brew for them. You know, it's pure research, something bold and dynamic. Custom built is saying this has been done before, but we have very specific needs. So we have tailored it and we have custom built the solution. Product is saying there's something we could buy off the shelf that can do this job. And then commodity is it's so ubiquitous, like electricity, that it doesn't matter where you get your electricity from. It doesn't change anything about the appliances in your house. All that changes is the letter that comes with the bill you pay. So to take those concepts and apply it to this graph, as I said, this is for a cafe, and this is for a user coming in and ordering a cup of tea. And what these circles are, is this is a decomposition of the value chain of the cup of tea. And all that really means is we're breaking it down into its components. So we have our cup of tea that is broken down into the cup, the tea, and then there's the staff member that has to take the order and physically give you the tea. But then to turn those tea leaves into tea, you need hot water. And to have hot water, you need water and you need a kettle. And then for the kettle to heat the water, it needs power. So the concept the 2 concepts I'm trying to demonstrate with this simple graph is 1, this company has the kettle in the custom built section. What kind of competitive advantage do they think they are gaining out of having a kettle that they have custom built themselves? There are electric kettles for sale in every single store, probably within a mile of this shop. And I have about 3 of them in the cupboard that half work. I could have given them one. And if you look at this from a cost sort of worth-based development perspective, the cup of tea costs 55 cents in this scenario. 15 cents of that is being directed into the kettle, and 5 cents of that is being directed into the power. So 10 cents on every transaction is being wasted on developing this proprietary custom kettle technology for the cafe. If they shifted that, if they evolved that capability to the right towards commodity, they would have, I don't know, probably 9 extra cents to invest in some unique selling point that could differentiate them from the cafe across the street. So that's the concept that we're going to carry forward as I talk about the serverless first mindset. It's code as a liability, and how do we reduce your liability by evolving pieces of your value chain towards commodity. Now, the main title of this presentation is AWS CDK, so I can't go any further without talking about what it is. And the official definition from the docs is use the AWS CDK to define your cloud resources in a familiar programming language. The AWS CDK supports TypeScript, JavaScript, Python, Java, and C#/.NET. Now, you might be sitting thinking that I just said code is a liability. So have I just become the biggest hypocrite ever in 8 minutes? Well, as you just saw, and it was demonstrated beautifully to set me up for this, your YAML is still code. If you are deploying infrastructure onto AWS, I mean, you should be using CloudFormation templates. If you're not, you're probably handcrafting it in the console, and that's a whole different conversation. But if you're using CloudFormation templates, you're writing YAML. And if you're not using a product, if we just talk about vanilla CloudFormation out of the box and we put it on a Wordly map, your user and the application is up the top. It's highly visible. They know what you've deployed. That application is deployed through CloudFormation, which is a complete commodity service, but your YAML is completely custom built. You have copy pasted infrastructure that everybody else in the world is probably doing the same thing because that's how it works. And then if you're referencing some custom resources, you've literally plugged a gap for something that doesn't exist in CloudFormation today. So you're squarely in that custom built sector. And I put in here can be more than 1,000 just to play it safe, but you just saw 2,500. So there you go. The whole point of the serverless first mindset and CDK and these products is they reduce your code liability. And Stackery is another example that could go here, along with others, Terraform, Pulumi, Begin.com. But the whole goal and the secret that nobody is telling you to be in that next level engineer that nobody understands how they can move so quickly. These products are not, a mutually exclusive offering. It's not a case of if you're using AWS CDK, I have to stand here and bash, amplify SAM or serverless framework. It's a case of what capabilities do each offer for the stack you're trying to deploy and how can they speed you up. Like I know, for instance, that there are teams that are combining CDK and Amplify today to get the rapid UI development and some of the the security functionality built into Amplify, and then importing resources into CDK and modifying them through a different stack. I also know that you can use some of the incredible local capabilities of SAM and combine it with CDK so that you can define your resources and then do all your testing local as if you'd done it in SAM. At the moment, there is no overlap, I know, between CDK and serverless framework, but that's just a matter of time. The ultimate goal is how can we use these products to write less code? I want to demonstrate this instead of doing like a full-blown live coding example for this. I just can demonstrate it with this image. On the left-hand side of the screen, you can see TypeScript CDK code, and it reads pretty well. This you should be able to understand that at the top, we have a DynamoDB table that is set to billing mode on demand. We have a Lambda function that gets passed in the table name as an environment variable, and then we grant that Lambda function, the permissions, the IAM permissions, to be able to run queries against the table. And then finally, we have an API gateway, HTTP API, where any URL you hit will go to that Lambda. On the right-hand side of the screen, this is the CloudFormation template that code produces. It's not a versus. It's the same as what you were saying with Stackery. These two things are the same. CDK out of the box comes with a set of what they call sensible defaults. So the items that I'm writing on the left are the things that I want to differ from the standard. We're looking at the delta. And that is an incredible, possibility that whenever we start to come and look at these things, that it's a case of going, I know what the standard is for all these stacks. So this is what you specifically wanted to change. And I know it will always produce that CloudFormation on the right. And because it maps to CloudFormation in an enterprise context, I can change any property in that CloudFormation and meet my compliance issues that are needed to deploy to an enterprise cloud. So we were getting the benefit of abstractions, but we also have full customization and ability to change any individual piece. You might be asking, though, I just said these two pieces are equivalent. How can you be sure that the abstraction on the left doesn't just get changed without your knowledge and the CloudFormation gets deployed different and then you're left in a weird state? That's why CDK has unit testing built in. And this unit testing is actually based on the CloudFormation template that is output. It's not based on the TypeScript classes. So you could do a major refactor, run these unit tests, and you should be confident that your CloudFormation template is exactly the way you want it to be. The big thing about CDK for me that I personally see as a bit of a game changer is that CDK loves patterns. It's called the Cloud Development Kit, but to me, they probably should have called it the Cloud Pattern Kit. And that is because everything about it is talking about everybody is deploying the same pieces of infrastructure again and again and again. And a lot of people are doing it either via UI tools that you saw that are taking snippets that paste it into your YAML, or maybe just crafting it by hand every time. But CDK has taken a slightly different approach. So the team developed this proprietary technology called JSII. And what that lets you do is define a piece of infrastructure that is the same for everybody, a reusable class, So on the example on the left, what I'm going to talk about is it's the infrastructure for deploying a single page app like Angular or React. And you can take your class, build it with JSII, and it lets you publish it to all of the package managers for all of the languages supported by CDK. So you write your code once, and it's available in TypeScript, Python, Java, .NET, and any other language that they support in the future. And it's not a clumsy implementation. If you look at the difference in these two, like TypeScript versus Python implementation, you can see that the create basic site method, in TypeScript, it's got the capital B and the capital S, whereas in Python, it's got the underscores. JSII did that for me. In TypeScript, it's taken an adjacent object, whereas in Python, it's using name parameters. So it's a completely native experience to the developer consuming these constructs, but it's a case of everybody is just pulling them in via their favorite package manager, and then they can get updates over time. And then the other way that patterns exist in CDK, and this is the thing that I have personally been building since January, and it's what I call CDK patterns. Basically, this was to fill a personal need that I had. So if you go onto Twitter or you go to medium.com or you watch reInvent or any of Serverless Day's events, you see some of the people on the right that are talking about cloud patterns and cloud implementations. But a lot of the time, what you would get is a picture of that implementation. And personally, I then got really excited and would go to my team and say, do you know what, we should build this. And there would be an issue where there's a logical leap that you need to take from the picture to a real implementation. You know, there's something that's been left out because it just doesn't quite look nice in the image, and it needs to be that way. So the pattern you can see at the front here is the Dynamo Streamer pattern. And that was Eric Johnson just tweeted this image. And he said, hey, you know, what do you think of this? If instead of going API Gateway to Lambda to DynamoDB, what about if you just went API Gateway to DynamoDB? And I took that and went, okay, every pattern in CDK pattern should follow the same contract. So you should just be able to clone the pattern, deploy it. It should have all the documentation you need to be able to understand what you've deployed and how you test it. So this particular pattern, you can just do that command at the bottom, npx cdkp init the Dynamo Streamer, and that'll pull down and clone the code for you to just run npm run deploy, and it's in your account. And the beauty of this for me is these are not my patterns. All I have been doing is consolidating the great stuff that is going on in the community and bringing it into one place under one contract. So that's why I have that bright yellow box saying that you could be the next person to be in CDK patterns. If you're building something serverless, this is all open source. So all you have to do is @ me on Twitter and we can talk about it. So before I go any further in the presentation, I did tweet to say I would talk about how AWS solutions constructs, which if anybody's been watching Twitter, how that plays in with CDK patterns. So this week, AWS launched a bunch of JSII constructs on the left called AWS solutions constructs. And what they are well-architected building blocks that have somewhat of an overlap with some of the patterns in CDK patterns. So that's another reason why this Dynamo Streamer pattern is at the front, because there is an API gateway to DynamoDB solutions construct. In order to make this CDK pattern work, I had to personally spend about 3 or 4 days working out the API gateway specific templating language VTL in order to do this, whereas now somebody has taken my code liability, produced an official library, so I can just use that building block and everything else about the pattern is still good. So those official constructs have just meant that I personally have less code liability and everyone else has some better building blocks. But essentially, the core construct of CDK pattern does not change. It's about community and it's about patterns. I just mentioned that those solutions constructs are well architected, but what does that mean? AWS created the AWS well architected framework a while ago, and it's built on 5 pillars. Every pillar has a detailed white paper and it lists the best in class implementations for how AWS think you should be building solutions. And that was brilliant, but it was a very long read and it formed the basis of the AWS certifications. But then AWS went one better and built the well-architected tool. And that's built into the AWS console where you can just answer, I can't remember how many questions it is for the full assessment, but you answer a bunch of questions And it gives you a report that says, here's the high risk items, here's the medium risk items, and here's the low risk items that you need to address about your code base and your implementation. But then they went one further again, and they said, do you know what, that's still a lot, because to do that assessment, you need to know everything about those 5 pillars, and those 5 pillars relate to everything about coding. So they built the serverless lens, and that's a very specific cut on the tool, and it specifically talks about the implementations in a serverless context. So that was awesome. And that's why CDK patterns, I built the well-architected pattern matcher. Header Lessa from AWS has helped me so much with this. But essentially, if you go in and you do a well-architected assessment through the tool, and say it comes up for Ops 1, how do you understand the health of your serverless application? It says under the first best practice, you should understand, analyze, and alert on metrics out of the box. Well, you can just use this pattern that I launched about a week ago, which will spin up a CloudWatch dashboard for your API gateway, your Lambda, and your DynamoDB. And it links to all the theory and all of the AWS advice. So it's a case of this is your real working example that you can just take and use and learn. And that's not where it stops. So AWS Well Architected covers a wide variety of capabilities. And that's why I don't know if you also noticed that Header Lessa launched the general availability of the Lambda Power Tools in Python last week. So it's a case of going to the next level and saying one of the best practices is being able to give business metrics and dashboards for your serverless implementations. So this is going to come soon, but you should be able to get a, oh, hold on, cart checkouts are down 10% today. Is something wrong with the website, or has our competitor done something that's reducing our sales? That's what serverless is all about. Developers focusing on the business value, understanding where your business are going. So in summary, what I want you to take away from this is code is a liability. You can use Wardley mapping to find out where yours is. AWS CDK and friends will reduce your liability to let you focus on the business value. And you can maintain high standards by using the AWS well-architected framework and some of the patterns in CDK patterns.
Excellent. Thank you so much, Matt. So an amazing talk there. Minus 1,000 points though for using the phrase as far back as the 1990s. Okay, the 1990s were yesterday. Let's be very, very clear about that point. So a few questions. First of all, you used the phrase sensible defaults and so on with the CDK, and that's a form of convention over configuration, but one of the issues that people tend to find there is that you need to know the conventions. Yeah, so there tends to be this assumption that you're using the thing as a shortcut, but you're a professional and you have awareness of what the right choices will be and instincts and so on. And the danger is that somebody who's coming new to the thing is going to be surprised by the conventions. Do you think that's a danger with the CDK?
So there's the sensible defaults that come out of the box in the CDK, and then what they're now doing is those solutions constructs come with well-architected defaults, and they shouldn't surprise anyone because they should directly align with the well-architected white papers. So I do think it's a case of, I think that should eventually merge back, and the default should be the well-architected defaults. But you're right, it's something we're going to keep having to have conversations about because defaults are important.
Yep, very good. And then a big +1 on the Wardley mapping. I mean, we drag it into all kinds of things these days. It's very, very useful. But as you say, one of the things about Wardley maps is everything's continuously moving to the right. So things that you would do manually will eventually become proprietary. First, they'll be automated, and then you won't even need to think about them anymore. So what things do you think people are doing today, within AWS and so on, that they just won't think at all? That it won't be a decision in a year or two's time?
So it's funny actually, because 6 months ago, a lot of the patterns that are in CDK patterns were in that almost Genesis space. And now a lot of them are commodities. So for instance, that Dynamo Streamer pattern, whenever Eric Johnson tweeted it, it was like people's minds were blown that Lambda-less is now a thing. For many years, everybody was talking about, do you know what, Lambda is serverless. And now we're saying, how many Lambdas can you delete? So the big commodity play, the big thing that is going to happen over the next couple of years is people are going to look at their architectures and say, we have a lot of lambdas in between a lot of managed services, but can those managed services just speak to each other directly? And then we, if they conform to some kind of event-driven contract, we're really managing nothing except for our unique selling point. It's pretty exciting.
Isn't there a danger there, though, that you end up reinventing the monolith? Because I can remember when this happened way back in the 90s, and databases like SQL Server, they started saying, look, we can receive HTTP requests as well, and you can build an entire web app in SQL Server, and you can use stored procedures as your REST controllers and so on. And then you got people who ended up basically doing everything in SQL Server, and that effectively became their new monolith. So do you think there's the danger of that happening within various bits, of AWS?
Yeah, I'd say if you implement it wrongly, you're going to end up doing that. But what you need to do is focus on how you can build what we call bounded contexts. AWS sort of refer to as cell, but it's the case of saying, do you know what? These two components need to talk to each other. We need to decouple this. So we should use something, maybe it's Event Bridge, maybe it's SQS, but we should be using events to decouple components from our architecture. And then we should make sure those events follow a schema so that it's not a case of having to spend all day trying to work out what the event was. And then internally to that, there's a contract for what it produces and what it sends downstream, but don't build everything in the one particular technology.
Cool. And then finally, you were talking about, every line of code is overhead. And as you say, that's an idea with a very long lineage. Yeah. So in the same way, from way back in the 90s, there's the idea that architecture can be viewed as a collection of patterns, and that if you're an architect, you're basically filling in the jigsaw with different patterns. And as long as you're well aware of the patterns, there is nothing else but putting the patterns together. Do you think that's a stage we'll ever get to? Or, as in the 90s, will it turn out to be a little bit of a dream?
So we're probably closer to realizing it with AWS than we ever have been, because for once I can see that we're all building on the exact same building blocks. And it doesn't even matter if you're using CDK. The point is, when you're in AWS, patterns become life. So that's why the patterns in CDK patterns, you can see the people tweeting and talking about them, they're talking about them in the abstract context, and then talking about how you stitch them together. That's where it depends, comes through the well-architected framework. So it becomes, should you use a kinesis pattern because you've got the high volume, or should you put SQS between your API gateway and your Lambda because you need to throttle it? So I think there will be a collection of patterns. I'm just not sure how big it'll be. And I always think you're going to need an architect to give you that advice on which is the correct pattern to go.
Yes. Yeah. So it won't just be a case of slotting things together.
You could do it, but it will probably work out very badly for you.
Very good. Excellent. Cool. So in the interest of staying on time, if I can banish you at this point, and we'll invite you back for the group discussion at the end. But if I can call on Richard then to give our third talk.
Hey, Gareth.
Hey there. And can I say that's an absolutely wonderful T-shirt you're wearing there. Where's that T-shirt from?
Why, that's a Kotlin T-shirt, Gareth.
Oh, that must be an amazing conference. Sounds like a great event, yeah.
Certainly is, yes.
I hear they have wonderful workshops there, yeah?
They do, yes, especially from Northern Irishmen. Thanks very much, Gareth. Okay, just one moment, I'll just share my screen. Yeah, so today I should say my name is Richard Gibson, and today I'm talking on function as a service, meeting a pattern called server as a function, which I probably have come across before, but a little bit of formalization behind that, and yeah, showing how we can use that to make Lambda functions better. About me, I've been a dev for way too long, long enough to tell other devs what it was like whenever I was a young dev, and I've been working with serverless technologies for the last 4 years, and just in the last year been helping to start up a company, XLabs.io, which we are using serverless technologies, relying on serverless technologies heavily just to get a product off the ground. So we really like them. We really like serverless technologies. We fully bought into that, and yeah, so it's been good. A little bit more about me. Garth was talking earlier. As he was saying earlier, I love to cycle, love to keep fit, and I'm in soon about to embark on a challenge which was supposed to be the length of Ireland next week, but unfortunately because of COVID, it's been postponed to next year, and instead we're doing a solo challenge. So 2 weeks time, I'm going to be trying to complete 500 miles over 4 days, and we're collecting for a local charity, Storehouse Belfast. They're a great charity helping vulnerable people in Belfast in many different ways. So if you want to take a look, there's a link there. Okay, so Lambda functions. So what are they? Very, very high level. They are basically a set of function, or Lambda function is a function that is configured to react to some sort of event in AWS, be it a file or arriving in an S3 bucket, or some message being sent to Kinesis or published from SNS. There are tens and tens of different types of events that you can have a Lambda configured to react to. But today we're just focusing on one type of event, which is when an HTTP request is sent to an API, to API gateway, which is their managed service that's used for HTTP requests, be it REST or WebSockets. Okay, so if you have done any work with Lambdas, this is usually the first stop. You'll see something in JavaScript of a hello world Lambda and or other language of choice. Just wanted to start with this just to show you, as it's probably one of the simplest implementations. So in this case, what happens, we have a function, hello world, takes an event and a context, and we're just returning something which looks very similar to an HTTP response. We've got our status code 200, we have our body string. Very simple. Just to show you a slight difference in this, and I should say as well, because the library I'm going to be talking about is in TypeScript, the last function would run in TypeScript, as it's nearly a superset of JavaScript, but also it does give you the added extras of being able to write in types, to use types in your code, and to be able to use compiler or type checker to ensure that you're getting this right. So while we have a little bit extra boilerplate here, or we have extra types here, it does mean that once we get to here, if I misspell status code or anything like that, I have a type checker there that's going to tell me that I've got something wrong, and I can catch errors early. So all good. So if I was to make a request to an API gateway, so this is our hello world Lambda deployed now in AWS, and we just make a curl request here. And just for hello, this is what we'll get back. So we can see some headers coming straight through from API gateway, and at the end, when we're doing our get, we get our body back. We have our HTTP 200, everything is okay. But once we're in our functions, what we're actually dealing with is, well, it's almost an HTTP request. You can see that the parts of it here, but it's in a slightly different format. So most of AWS does run on JSON. So we're going to have to work through a JSON structure and extract things and work with that inside our function to get more, to get some value from it. Yeah, so once we do want to get some more value from it, while we don't want to have functions as large monoliths, it is quite normal and natural. What we find in our experience that we want to be able to maybe use a function for more than one different HTTP endpoint that's deployed out. So once we start to do that sort of thing, suddenly the hello world that we have does start to get buried in a lot of other stuff and a lot of other boilerplate. So we could be checking to see if it's a get or if it's a post. We could be authenticating. We could be checking the endpoints, doing any number of things, maybe adding cores. And so what we find is that after working with functions for a little while, usually we ended up trying to find fancy ways of bending over backwards to try to remove this and minimize this as best we can, so that if we spell get wrong, that we're not going to be sitting for the next 3 hours trying to debug our code, figuring out what's going on. So yeah, things that we missed. These are in the last slide. If you've worked with any other HTTP framework, this stuff is a given that we just would want to have there. So things like just some sort of error handling, being able to take path parameters or query parameters or headers, just being able to grab those and as certain types, being able to authenticate. Although that can also be done inside the AWS infrastructure, and stuff like marshalling out of from JSON into your objects. So what I should say at this stage is that, yeah, as I said, we did explore a number of different ways to do this over the last few years, and we came across a framework that's called HTTP for K. It's in Kotlin. A lovely framework which can be used for Lambda functions, but also on top of lots of other different server implementations. And just this was based off of a paper that was written 7 years ago now, and called "Your Server as a Function," and where we got this title from. And this is by a guy, Marius Eriksson from Twitter, who started up a library called Finnegal. And basically the ideas in this paper were used in a number of different Scala and Kotlin libraries. And probably if you were to see later on, stuff like Webflux and Spring also would be influenced by these sort of ideas. So he tried to formalize that actually your server is just, as he says, a function. It's or a server could be just seen as a service. It just takes a request, and because we're in the 2000s, it would return an asynchronous response asynchronously. This future structure here is saying that we have a response sometime in the future, and that's us. That's all we're doing. A simple way. But basically, well, he actually coined this as like a basic building block that we could use, and then also came up with another structure called a filter. And the idea with a filter was that it was something that could take a service like this and then return a new service. And the type signature here is a little bit complicated, but we'll show you again in TypeScript in a few seconds, and it's a little bit easier on the eye. So just to say, so what we used HTTP for K for quite a while, and really liked it, very happy with it. The one thing that we had a problem with was just using lambdas in the JVM with cold starts, and just with overhead as well, with the size of jars. We find that we could sometimes have performance lags when we were hitting our APIs, which we just didn't want to have there. So I've worked on the JVM for years and had to, I've probably dragged kicking and streaming into the JavaScript world. But we decided to move to using TypeScript instead because of the response times were just so much better for us, especially with things like cold starts and lambdas. So API, as I said, we've been using TypeScript for quite a while, but we missed this sort of pattern that was in HTTP for K. So we decided to write something similar in TypeScript, which we're going to show today. And so API Gateway TS, it's a small library, as I said, written in TypeScript. And it's probably about 10 to 15K in size. So very, very little overhead that way. We don't have any dependencies in it. So whenever you run npm install, you're not going to see the world being brought to your computer. And also with these structures in the servers a function paper that we're showing, it makes some very testable and composable components. So this service that we were talking about earlier, this is how we've modeled it. So instead, we've called it a handler, which actually falls in with HTTP for K. And what we've said is our handler is just a function that takes our event, which is this API gateway proxy event, the same structure that I was showing earlier, and returns asynchronously, which is why we've got this promise, an API gateway proxy result. Nice and simple. How does that look in Hello World? Well, sort of the same. I mean, if you're familiar with Lambda functions, it's pretty much the same idea. So we have our Hello World handler, and what we're doing is we're saying asynchronously, we're taking an event. This is sort of just syntactic sugar for using promises or using something asynchronously. And then, so we take our event, we're not actually doing anything with it. We're just going to return our status code 200 and body okay, all good. But we need to then also bind this to a resource. So when will this handler be fired is basically what we're going to say. So to do that, we have a function called bind, which will take your resource parameter, so something like hello, and then an HTTP method get here, and we are able to bind this to a hello world handler. And actually, when we do that, we store this data, but we're still using a handler type, which is quite important for later on as well. So once we have a few handlers like this, we have bound our different APIs. We need to be able to match and find out which handler we need to use based on the resource path and method. For that, we're going to use a construct called a router. And the router just takes a list of handlers and then also has an optional here of a response that could be returned if none of the handlers are able to actually return anything or find anything. Because each of these structures are a handler, we're able to nest these things. So if we want, we can actually just nest this way. So we could say on our endpoint ID, we want to be able to get, patch, and delete. That's all fine. We can use that. Or if we want to get all with just slash, or we can use just a .get in here as well. Just probably to say as well, bind, it uses a lovely thing called a union type in TypeScript. So it means it's type safe, but we can either give the method a string or a tuple or a pair of both of those. Okay, so moving on to the other component we're talking about, filter. This hopefully looks simple here, but can start to get a little bit complicated. So if we say a handler is a function that takes a request and returns a response, well, a filter is a type signature for another function that takes a function and returns another type of function. So it takes a handler and it returns another handler. Now, it sounds a little bit complicated at this point, but it should hopefully make sense when we see a little implementation. So here we have a timing filter. And the idea is that the filter is going to take our handler, which is called our next handler, and the handler is going to take an event. Okay, so bear with me, hit this one. And with that event, what we can do is we can intercept that event before actually calling the handler. So we have our event here, and we could maybe change it or just update it or create a new event. But in this case, all we're going to do is take the current time and then call the handler. And on the completion of the handler, take the time afterwards and log the difference. So they're very similar in probably to like servlet sort of filters as well, if anyone's used to that sort of side of things. So because a filter, because of the structure of a filter, it just takes a handler. Well, what happens is that we can actually just stack these filters up. So say we have an timing filter, and then we have another authorization filter. What this does is this will actually mean that we now are able to pass one inside the other and then pass the handler in here. And now from all of this, from these two filters calling each other and the handler, we have another handler. So this means that we can use these in isolation, or we can stack them. And obviously, when we run these, it means that we're going to have our auth filter run first, and then call our timing filter, which will then call our handler. Now we can do it this way, but we've also just made some convenience functions in the framework where you can just take a list of filters and they will stack them up in order for you. Okay, so quick demo. Okay, so just make this a little bigger. So I've just made a very simple to-do endpoint or application that we're using. So we have a few different functions here, and what I've done is I've just put everything in line as far as what the implementation is. So we have this to-do router that's going to be able to add and delete and get chores that we have in our to-do list. So if you want to, so as you can see, we just have, this is our to-do service that's going to do our business logic, go on, pull everything from the persistence, push everything. And the idea is that if we, the idea is that if we hit an endpoint that has an ID and it's a get method, then we can go get the ID from this required path parameter, call our service, fetch the data. If we get something, we've got a 200. If we don't, we have a 404. Again, if we're going to do a put operation, same idea, go grab our path parameter, take our to-do entry from the action that's actually being posted with the put request, and then save it in. Or if we want to delete, again, we get our ID, and then if go grab the entry, if it's there, run a 200 and delete it, and otherwise just run a 404. And we also have a couple of other endpoints here just for a get, to be able to get all, and then we have one that's called a post as well, just to create any new to-do items. Also, as you can see, we've just added this thing for filters. So what I can show you is, in this case, we have a couple of, with the framework, we have a few filters out of the box. So we have, in this case, I'm using just a console logging filter. So that's just going to take the HTTP method and the path and log that, and then also log the response whenever it's completed, so we can see something in watch. Then also we have an HTTP error filter. The idea with this is that we can catch any errors that are that could come if, say, a required path parameter isn't there. We can then respond with a good useful error, like a 400, with some sort of useful message in the response. So nice and simple, all put together. So just to show you, I've deployed this out this morning. So I'll just go over here, and we can show you just in, this is just a little dashboard that we use in Hex Labs just to show our inventory. And if I just search for demo, which is the name of this, the stack that I've deployed out with our Lambda, you can see we have we have our Lambda here. We have a DynamoDB instance, and also we can see our API gateway stuff, resources in there as well. Okay, so just to move over to actually hitting this API. So if I go in to Postman, I can just quickly call a fetch, and we can see that I still have some to-do items in here. If I go try and fetch one, it's all working fine. I will just go and create a new one. Go to bed. Just get rid of the ID. And we've created that. Let's say we're going to complete that. We'll do a put. Oh, and I've done wrong. 1 second, sorry. Let's do a put. And we are good. Let's just change that. And then we can also just delete it as well. Okay, and so that should now go to bed, should not be in here. And we are good. Just as far as testing this as well. So I'll just go back here. Although this isn't too different from how you could test any functions. What I've just done for this is I've just created, very simply created a to-do service that we're calling a business logic as an interface. Because I've been able to do that, I can just create an in-memory service as well. And whenever I actually create my API, get the to-do API that I have, I'm able to pass in that service. And from there, I'm actually able to just run my unit test on it as if it were just something run on the function, just like any other code. So it's nice and easy to test from there as well. Also, things like the filters, because they are doing everything in isolation, they shouldn't be dependent on each other in a chain. You can slot in a very easy echo type handler, call a filter, ensure that it's doing exactly what it's supposed to, and no more. So it just lends itself nicely for nice, easy, testable components to use. Oh, and just to show as well, I guess, proof that we're actually running here. So if I go to my logs, I was saying there was a logger in there as well. So they should just have been called. Yeah, and we can see that here we have our deletes being called, saying that this is a delete. It's a request that were called, and yep, we responded with 200. So everything is working fine. Cool. And that's everything from me, short and sweet. But if you're interested in this anymore, I've stuck the demo up on GitHub, and also there's a link there as well to the library itself. So it'd be great to know if anyone's using it. Let us know. I'd be happy to help if there's anything else, any other information you want. Okay, thanks.
That was excellent. Thank you so much. Just to ask a couple of questions there. First of all, lots of love for TypeScript. You know, we use it all over the place, and it's wonderful. And some of the new features in it are amazing. And also the white paper is great. And I've used HTTP for K and HTTP for S. Just to mention, there's also HTTP for J. You know, so if Java is your main language and you want to check out the implementation of that architecture, there's a Java version of it as well. So I think the first question would be, you mentioned that there's Spring Webflux, you know, and I've seen a lot of talks with people trying to embed that in AWS, and you've got the Keynote people doing the same thing. Just to give a shout out to one of our sister user groups, there was the Dublin Kotlin user group had a superb presentation recently where I think it was one of the Quarkus, you know, core developers was on, and he was talking about all the tricks they'd used with Graal VM to try and cut things down so that their framework, you know, would fit in. So just to ask, do you think there's any point to that at all? You know, is there any point trying to get JVM frameworks into AWS Lambda, or you know, should we just embrace the world of JavaScript through TypeScript?
Well, you know me, so I love JVM. So it took a lot for me to move over to JavaScript, and including making my own custom Lambdas on GraalVM, trying that out as well. And you know, it was getting close. I think GraalVM's getting close in times for cold startups, but it's still it's not just there. It's not just as fast as JavaScript. So it would be nice. I think also the fact that just the footprints as well. I mean, as I said, literally with that, we're able to create Lambdas that are just you know, 50, 100K. So they're tiny, and so they're easy to deploy fast, and you know, they're cheap to run, even cheaper to run than the JVM settings. Not to say we still use Kotlin, and we still use it on the back end of things as well. You know, so if we're processing stuff from SNS or Kinesis or those sort of things, we still love using that sort of things. Just you may find AWS are able to do something else with this, you know, over the years as well. Not sure. I mean, it hasn't put us off them, but whenever you see spinners on your web page, and you know it's because it's JVM, it does feel a little frustrating that way. Yep, definitely.
No, well, I know how much, like myself, you love the JVM, so I knew if you converted, there had to be a good reason for it. So absolutely. So next question. There's clearly two advantages here. It's simplifying things, and it's also giving you a little bit of insurance, you know, a little bit of abstraction from the underlying cloud platform. So two-part question. Which of those do you think is most important? And do you think this is something that people can use as a kind of intermediate step to kind of ease their way into a serverless architecture?
Okay, so I think that it's nice because it gives a little bit of familiarity. I mean, so as I said, it is quite similar to a lot of other frameworks. Although saying that, with serverless side of things, I don't find the code as much of a difficulty as the deployment and what Matt's been going through, and you know, that seems to be more of a problem in that sense. Definitely, if there's a way that we can use the type system to be able to catch things earlier, I feel a whole lot happier with that side of things. I still feel very nervous as a programmer writing stuff that I feel like I have no idea whether I've put a typo in here or anything of that nature. So yeah, I think it should look familiar for most people. Yeah, I think it's what we feel. It's a very small library. It's 200 lines, so it's pretty lightweight. So it's not a big overhead to use or to drop down to the core stuff otherwise. Yeah.
Cool. Very good. So I do have a couple of other questions, but I think that these are questions that we would appreciate the other speakers' views on as well. So at this point, if we can just move into the general Q&A, and I can invite our other two presenters to join us. Yep. And then if I can ask the question, and I'll give Richard first crack at it though. So the question would be, we've seen three ways of simplifying, so we've had three great talks, yeah, and we've seen that you can simplify things by working at a kind of higher level, at a visual level, and so on. And then we've seen that you can simplify things by boxing and commoditizing your architecture and using patterns and so on. And then we've seen that you can simplify things by putting in your own kind of very, very thin and efficient, insulation layer. Okay, so do we believe these three things are compatible? Can I have 3 out of 3? Can I have 2 out of 3? Or do I have to pick one? Okay, and can you give me an answer that doesn't use the words "it depends"? Okay, so Richard, if we start with you.
I feel like doing the yes/no game, except I'm not allowed to say it depends. It's just not fair. Well, it's a case of what sort of. It's very hard to give something very simple and very powerful at the same time in all software walks. It can be done, but obviously the more power that you're giving over, the more of a learning curve, the more step up you have to have. So, hard to know in these cases. I mean, definitely if you want to get something up and off the ground really quickly, it makes sense, and you maybe don't understand or aren't as familiar with the ecosystem, and you haven't had, you don't want to spend the next 2 years trying to ramp up on that, and there's people with expertise. It does make a lot of sense to use that and use those tools there. So is that?
Yeah, no, very good. Enough. So Chase, same question to you.
Yeah, yes. I think one of the things that is common of all of these approaches is they're compiling down to CloudFormation at the end of the day. And so there's some different techniques to get to that point. But then once you get to that point, there are some commonalities that you can also build on top of. So for example, inside of Stackery, we have mechanisms to deploy serverless framework and CDK. And then once that's deployed, we can retake that CloudFormation that's been generated and render that back to you, so you can see and overlaid with metrics and things. So yeah, I think you can have everything in different ways depending on how you construct your tool set. And that just gets back to what's the right tools for the job that you're looking for, as Matt mentioned this in his talk.
Cool, very good. So yeah, over to you, Matt.
Yeah, I mean, so not to repeat my talk slide or anything, but I think that CDK is aiming for this line where we're saying that CloudFormation should become WebAssembly. And the idea behind that is it's a commoditized resource. So like you could take that CDK CloudFormation template and pump it into Stackery and get the UI view, start playing with it, see the delta, and then go back to CDK if you want. The point is about the outcome. And we now have all these options and these tools for whatever most represents you in terms of your thinking process. So I think you should be looking to combine all these paradigms just to speed yourself up.
Cool, very good, excellent. So next question then, would you all feel confident in saying that, and I actually like the way, Chase, that the sun is coming up behind you, so we're in a bright new dawn. I love the metaphor here. So are we now saying that we can skip Kubernetes? So for example, if you're one of these slackers who hasn't actually bothered to learn Kubernetes yet, would it be possible to just jump that as something that's now proprietary, and you don't have to worry about it, and just move directly into the world of serverless? So, and whoever wants to go with that.
Yes. Kubernetes has, where it is being used, it's being used because it is a common abstraction that you could use across a data center into different cloud providers and so on. But when you do so, the benefit that you're getting by having that common abstraction is that you're not actually fully leveraging your compute resources effectively. So you've got a higher cost. The abstractions, like with Kubernetes, you have to operate everything yourself. If you need a database, you have to figure out how to run that database. If you need a queuing service, you have to figure out how to run that queuing service. So you don't have the ability to shift that off onto your cloud provider. So there are some extremely heavy trade-offs that not everyone takes into consideration when they think about the nicety of, oh, but if I'm using Kubernetes, I can lift and shift this anywhere I want. So what I mean, the direct answer is yes. You don't need Kubernetes. For most workloads, you can accomplish the same tasks faster, easier, cheaper with a serverless approach, as long as your organization is going to let you do that.
Cool, very good. Anybody want to add to that?
I'll just add, so we have some software that runs at, frankly, a ridiculous scale in the serverless context. And I would not like to personally try and refactor it back to Kubernetes. So it does have a place, but that's why we have that serverless first mindset. So we start with what is the least amount of code we can write. And if you can prove to me that the value justifies spinning up a Kubernetes cluster, I will support you 100%. But you should start with the serverless solution first and work your way back.
Very good. Cool, grand. And we're after time, so I think we'll just throw in one more question, and then we'll call it a day, a very early day. So the question would be, you know, the downside of this, of course, compared to a kind of monolithic approach, is that you're going to have a lot of moving parts. You know, so let's say I'm an architect and I'm trying to conceptualize this and keep it all in my head, and but be aware of all the different bits and bobs and so on. Would you be confident enough that the tooling and the visualization tools, that we have these days, all of them, taken together, would enable me to have an overview, or is there a danger that you're just going to start losing track of things? So anybody who wants to do that one?
Sure, I'll go first, because seeing as I'm working on just something similar to that. Yeah, we feel that there still is a bit of a hole just as far as inventory, being able to say, hey, what's in my AWS account? And whereas if it's well policed and well looked after, it is okay to keep track, but to be able to just point at any AWS account, say what's running and how much it costs, and it is a tricky task at the moment. So I think there's tooling on there's a number of things that are on its way, my company included, are looking into how to do that, how to get those inventories, and how to look at costing of each of those resources. But there's a number of people that are looking into this, and it's a big topic, as I say, because people are trying to, they're moved into this sort of environment. How do they keep their costs down, and how do they do, how do they pick off stuff that's, because there are certain places in AWS that you can get stung if you're not looking after this stuff just as well as you should be. So,
cool.
Yeah.
Anyone else want to weigh in on that?
Matt, are you and I like going first on this? Why don't you go?
Okay, so obviously I have an enterprise cloud that we work into, and I sit over a couple of hundred developers in Belfast and Dublin, so I'm in this exact situation. And the way we do it is, first of all, we have very strict controls on what you can deploy to our environments. If you try and deploy something, and say you try and deploy a database without encryption, it just gets deleted before it gets anywhere near an account. On top of that, everything that's deployed has to have appropriate tagging so that we can pull it back and break down costs, both based on business area and application. So there's a lot of work that needs to go into your account strategy, your tagging strategy, and even just communication with your developers on coming to you and doing a well-architected review, and actually sitting down and saying, okay, what are you building? Let's map it out. Let's go through all of the questions, and let's do this properly. That's how I manage the process.
Very good.
Yeah, I think that's the key thing here is there are certainly people who've gotten ahead of themselves, and they need to find and identify tools that can help them inventory what they have existing in their account. But the real solution is from the beginning of a project is understanding how do we group the resources within that. Tagging is one great mechanism for that. How do we manage concept of an environment, because AWS doesn't have a literal concept of an environment. It has an account within an organization's, which is the best thing that they have natively. But an environment really is a bit more than that. But it's also like, because AWS hasn't defined it, it's an abstract conception that you have to figure out how you manage yourself. So once you start to have a sense of how you define an application, how you define an environment, you now can build the processes to support those, and you'll find yourself in a much better place.
Very good. Excellent. Cool. Well, listen, we're past time, so I think we shall call it a day there. So thank you so much again to our speakers. If I can just dismiss you one last time and send you away. Thank you so much. And to all our viewers, I think we went over 180 at one point there, so that's absolutely excellent. Thank you so much for attending, and hope to see you all next time. So thank you very, very much indeed. Cheers.